Well, I hope everyone's having a great CodeRage today. There's been lots of interesting C++ sessions and many more to come. My session over the next half hour is a overview of the C++ language. These are the features of the C++ language specification that I find particularly important or worth noting, and that you should take some time to learn about and start integrating into your existing code or new projects. So I am the director of application developer products here at Embarcadero Technologies, and that means I'm responsible for product management and product marketing for all of the developer products, which include C++ Builder, Delphi, Rad Studio, Interbase, App Method. But probably more important for this particular talk is that for you to know that I'm a C++ developer at heart, and I've been developing C++ pretty much since it's been around, having been an early Turbo C++ user during my teenage years and growing with Borland C++ as I came to work at Borland as an intern back in the early 90s, and growing up with their C++ products pretty much through that whole phase into C++ Builder as well. So you can contact me directly at jt@embarcadero.com. My Twitter handle is at FireMonkeyPM, and there's my blog URL, so you can find me on the community under JT. And let's talk about this session. So in this session, we'll just do a brief history of C++. More specifically, it is Embarcadero's history and relationship with C++. The next thing we'll get into are features of C++11 I think you should be using now. And there's a mix of library and language features. They all, work together, of course. And I'll try to provide a detailed explanation of each of these features and show you some example code as well. And then at the end, we'd be happy to take any C++11 specific questions. Actually, I'll take questions of any type that you might have. But if they're too off topic, then we may have to answer them outside of this session. So let's jump into it. So I think most people know the history of C++, having been created by Bjarne Stroustrup. By the way, in case you don't know, and you should by now, Bjarne Stroustrup will be presenting at CodeRage tomorrow. His session is 9 a.m. to 11 a.m. Pacific, and he will be sharing his talk from CPPCon, at which I was present, on making simple tasks simple. It was an excellent talk. It wasn't just about C++, although C++ was used and talked about quite a bit, but more about, as programmers, as developers and engineers, how we should think about problems and not trying to overcomplicate solutions for the sake of overcomplicating them. So highly recommend that talk. Bjarne will also be available for a live Q&A afterward. So back to that history. My understanding is Bjarne, having, working at Bell Labs at the time, they had some very challenging engineering problems to work with. It also required great performance. So C language was largely used as the development or implementation language due to its performance. But because of the data sets they had to deal with, they really needed an object model to work with. And so this spawned C with objects. And looking at other object-oriented languages at the time, like Simula and Ada, for guidance, C with objects was born. But its syntax and its RTL and with a big goal of compatibility with C, so you can intermix C code and C with objects code at the time. So this was a pretty basic implementation, had classes, had some inheritance, and a few other things. And if you were coding in C++ or C with objects back then, even early C++, you probably remember that there were no C++ compilers. Pretty much every commercial compiler out there was a C compiler. So instead you would use a front end called CFront that would read the C++ code or the C with objects code and generate equivalent C code that you would then use to build with your C compiler. So since then, this is 1979, a lot has changed throughout the years. And one of the early adopters of building compilers and building C++ developer tools was Borland. and probably most notably the Turbo C++ line of products. As I mentioned, this was my first development environment with C++, and I loved it. It was not only a good C++ compiler, but an integrated editor and debugger, and additional tooling around building C++, good C++ applications. And of course, Borland was also building frameworks and class libraries around C++ that were very popular at the time as well. So Borland got in pretty early and was a big leader in C++ over the years. So getting to where we are now, Borland went through a few iterations of C++ support and products. So Turbo C++ into Borland C++, and eventually right around the time C++ 98 was released, the C++ Builder product, which everybody on this call generally is using. So it's a C++ language development environment with the development methodology that was popularized by Delphi, and being able to visually develop your applications. And of course, we all know this is the most productive environment out there, with especially with C++ language support. So mid-2000s, Borland created CodeGear, which was the focus on the application developer tools at Borland, which eventually got bought by Embarcadero. And since that acquisition, Embarcadero has been investing heavily, not just in the developer tools in general, but also very specifically in C++. And with the express goal of supporting C++, but also supporting multiple platform development. So as you all know, we've done a lot of work to enable you to build applications, not just for Windows, but also the most popular mobile platforms out there, iOS and Android. And to get there, we utilized a C++ compiler project, Clang and LLVM. And we brought our extensions, our special sauce, to this front end. And in CBuilder XE3, we delivered the first version of this for 64-bit Windows apps. And since then, have enabled this also for iOS and Android. So we continue to invest heavily in C++. Here we are at C++ Builder XE7. And now you have basically the major desktop platforms, the major mobile platforms available to you, the ability to work with cloud services, and also work with backend as a service and your own middleware, as well as gadgets and wearables with Bluetooth. So really an environment for today's problems and tomorrow's problems using C++, common source code base across all of them. And so the architecture behind this is, like I mentioned, implemented around Clang and LLVM, where Clang represents the language engine in this scenario. And we brought to Clang our core features, property method event, support and syntax, which we also kept compatible with existing code, as well as RTTI as another example, and advanced features like exception handling, for example, on Windows, which is was a big part of the delivery of a commercial compiler for that platform. So this language engine, largely based on the fact that it's based on Clang, and also our additions to Clang are compatible with the standards with Borland C++, C++ Builder code, and all the popular libraries, including STL, Boost, Loki, Ace. We support the Dinkumware STL on Windows and Mac, and we use the platform STLs on iOS and Android. So after the front end does its thing, it generates an IR, which is compatible with the LLVM backend, and the LLVM backend then generates Intel or ARM instructions based on the target platform. And so again, the benefit to you is that you're using the same source code now across all these platforms, and you're getting the best performing executable on those targets. So we kind of walked through this already in terms of standards, but the one thing that's interesting to me is sort of the length of time between standards. Most notably, C++ 98 was a big release because it introduced templates into the standard. It introduced the STL into the standard, and many other interesting features, which most of us know as C++ today. But there were also some things that were challenging to use in it, or not quite complete, or just missing. There had been some additional work throughout those years in technical reports, generally speaking, that try to address bugs, if you will, in the specification. Most notably, the keyword export for template exports added in C++ 98 and removed in later releases because it just wasn't a practical solution. And during those years, and I had participated on the standards committee a few times around this, along with others, the goal was to deliver a new version of C++ that focused on simplifying some of the more challenging aspects of using C++, and also add some more powerful features that we knew were missing in the language or the specification, but largely implemented in Boost. And throughout the 2000s, the goal was to deliver it before 2010, so it was called the C++ 0x version, and it ended up being 2011. And here we are in 2014, just a few weeks ago. C++ 14 was ratified, and it was a minor update to C++ 11. So C++ 11 really is the new standard. C++ 14 does add new features, and of course that's going to be the latest thing to compare. But C++ 11 is when most of these major features were introduced. As you can see here, this is just a partial list of the features that were added to the language in the library, but it's pretty large, pretty complete. Probably the most notable thing missing that's been talked about is the concepts feature, and that's something that you'll hear Bjarne talk about also in his talk tomorrow. So that's a very interesting feature that is yet to be ratified in the standard, but I think it will be here in the near future. So I'm going to talk about some specific features as we go through the next 20 minutes or so that I think, for me personally, have been very useful in using C++ and updating my code and then making it easier to work with or read or have others work with, read, and also just solve some problems that were very easily solvable or required an a Boost implementation to try to solve it. So let's start basic. Probably one of the more basic features in terms of implementation is called the auto keyword. And auto keyword is all about type inference. So you use this when you want the compiler to deduce the type for you. Perhaps you don't know the type on the right side of the assignment operator, so you want the compiler to figure that out for you. Or if you're very explicit, like in these assignment operators, then you'll get exactly what you expect. In the top one, you get an int. In the second one, use the F designator, you'll get a float. In the bottom one, when you create a pointer to a new class, you'll get a pointer to that class. So auto, it seems like a very basic feature, but it really shines when you're working with template classes and you're working with the STL in particular. It really helps with readability and also dealing with common errors that you may otherwise run into, especially during compile time. I can't recall how many times I've pounded my head against the wall when I've tried to create an iterator class or some other type of template reference, and the type was just off a little bit, and you get pages of template errors. And it's very difficult to go through all that and try to figure out exactly what's going on or what the compiler's thinking. So auto resolves a lot of that. And most notably when working with STL containers and trying to create an iterator type. Iterators are a critical feature of working with STL containers. And in the past, you would have to know exactly the type, create that iterator, the readability becomes suspect because it can be very long and also can be wrong. So auto now really just takes that challenge and makes it a lot easier. You just create the auto I, and you can assign it map begin, and you're going to get an iterator that you can work with from that type. Now, when you use auto and the new ranged for loop, it becomes even cleaner. So the new ranged for loop is basically same as a for each. and it's used for looping through containers. Anything with a begin-end method is able to be run inside of a ranged for loop. The basic way it works is you create a for loop. You assign the left-hand value is the iterator in quotes, because it's not like your traditional iterator, and I'll explain that just a little bit more in a moment here. Use the colon operator, and then you specify the container class that you want to iterate over. In this case, it's a map. So a couple things to note here is when you're in your actual code, you're referencing that left-hand value as the variable name, and you're getting a value back. You're getting a copy from that container class. So that comparing that to how you would do it previously, you would have an iterator type that you would have to dereference in order to get a value out of the container. So now you just use it by value, and you get that value. If you want to use, if you want access to the reference instead, because you don't want it, the cost of copying, you can use the reference auto reference I, for example, and that gives you the ability to modify, or a const reference if you want to get the read the value but not modify it. So in this example code, building a standard vector of strings, initializing it with some elements, and then iterating over it with the range for loop using that auto I, and you can see here that I is referenced by variable name. No need to dereference it to get that value back. Another important addition to me is the new smart pointers. This is basically the C++ version of automatic reference counting. Automatic reference counting, if you haven't used it, is, I think, a wonderful tool. It helps you manage memory a lot cleaner. In the past, of course, you would have to be very careful whenever you created a new object to make sure that you deleted it within that scope. And of course, C++ is notorious for being able to write enough code or write code that can have memory leaks and can cause problems if you don't follow very specific conventions, making sure that you delete that memory. So auto pointer was used back in the C++ 98 days as a way to manage the lifetime of the object within a function scope, basically. So you can use an auto pointer, and you didn't have to worry about calling delete explicitly. It would be called when the function scope ended and the auto pointer was pushed off the stack and knew, okay, I need to go clean up this object now. So that's kind of the poor man's version of ARC. But what if you're dealing with objects that are well beyond that function scope? So this is where these new smart pointers come in. And there's 3 of them, and they all have very specific purposes. So unique pointer is used when you don't want to share ownership of the memory. Now you can transfer ownership, but you also need to now use the new move semantics, and I'll talk about that in a next slide. But unique pointer is about when you know I'm the only one, or this is the only variable that's ever going to have access to this memory. Shared pointer, on the other hand, is when you want memory to be shared. And basically, this is the reference counting aspect of it. So if you're doing assignments, what you're getting is a pointer to that type, but you're also reference counting it. So you know that there is another variable out there that's referring out to that type out in memory somewhere. So you can't get rid of it until all these references are eventually let go. Weak pointer is a way to deal with shared memory ownership, but in certain cases, and actually there's many data structures that this can happen in, you can run into reference cycles where you're double referencing. And so this is a way to specify or break those chains or those cycles so that you can keep that reference, but you don't run into this double reference type of situation. So looking at the first code sample here, you create a unique pointer. You create another unique pointer that's going to get access to that pointer. And in this case, you use standard move with a move constructor. And the ownership is transferred to P2 in this case. P1 is then no longer has ownership of that memory and is assigned a null pointer. In the next one, the shared pointer, this is where an assignment happens from another shared pointer, and in this case, both of those variables are going to have a reference to that memory, and therefore a reference count is used to keep track of that. And in the last one, where I use a weak pointer to access that shared memory, this is where I specifically don't want there to be a reference count. So I need to be aware that my weak pointer is going to reference something that could go away. There's no reference counting done. But then you use this again to solve some of those cycles that you may otherwise run into. So that brings me to move semantics. And move semantics, I think, are a really powerful new feature. It deals with R value references, these temporary objects that otherwise are immutable, but now you can modify them. And so basically the way it's implemented is as a new constructor and a new assignment. So this goes back to sort of the canonical 3 when you're building an object and dealing with lifetime kind of stuff. Of course, you create the constructor, you create a copy constructor, and you create a destructor, as well as an assignment operator. And you can also deal with shallow or deep copies as required for your assignments, depending on what your needs were. But those were the 3 things you had to do in order to make this work. Now, with move semantics, and you saw that being done with standard move in the previous sample, you need to create a move constructor. And it looks just like a copy constructor, but it uses a double ampersand, this reference, double reference symbol, to specify that it's a move constructor. And you can, of course, overload the assignment operator as well, just like you would in a typical copy assignment. This would be your R value assignment operator. Okay, moving on to some other features, uniform initialization syntax. This is one that I particularly like because I like to initialize STL containers, and in the past you would have to dynamically populate them using loops and using pushback and those kinds of mechanisms to fully initialize that container. But uniform initialization syntax provides a common way now for all assignments to happen. There's probably about 5 or 6 different ways that you can actually initialize a variable due to the lineage of C++, due to its, let's call it, sporadic compatibility with C over the years. Now this is a standard common way to initialize a variable. And so in this case with the standard vector of strings, what you see is me creating that type, giving it a name, and then using the curly brackets to specify the values separated by the comma operator. So this is a simple example, really useful feature though. Another one that I haven't seen a lot of people talking about, but I think is pretty important, is override and final. And this improves hierarchy building and management and deals with typical inheritance issues or mistakes. So for example, let's say you have a virtual function and it has a return type event, but you create the derived type and you mean to override that function, but you use the wrong return type. Let's say you use a long. Well, you may think that you've overridden that virtual function when in fact you haven't. They have different signatures. There's no way to know that until you're debugging this thing and you notice, oh, wow, I am not actually overriding that function. It's going back to the base class for that function. So override is a way to indicate that a method is supposed to override. So the good news here now is a compile time error. If you say I'm overriding this function and it doesn't see the same signature in the base class, you're going to get a compiler error. The one that goes along with this is final. So final is saying, okay, at this point, nobody can override these functions anymore. This is the final method that can be overridden in this version of the class. So it will see a combination of those in this code sample where we have a base class that has a virtual function called func, and it has an inherited class called foo, and foo overrides it. So in this case, it will be allowed to override because it has the same signature, but it's also making sure that this one is final. So now when we have another class called bar, which inherits from foo, and we try to override it, you'll get an error. It can't be overridden. So this is a good way to clean up and also address any kind of strict hierarchies that you want to portray using these new keywords. This next one is kind of a simple one, but I think it's really useful, which is that null pointer is actually a type now, as opposed to pound defining null to equal 0 or using it for booleans. The drawback of that one is that it really there's an implicit conversion to integral types with using a integer value like 0. Now, of course, you can use that for Boolean expressions as well, but it's not a Boolean. It's actually an integer. So null pointer here is a new type in the standard namespace. It represents a null pointer literal. It's no longer just a integer value. And that means that although implicit conversion can happen from null pointer to null pointer value of any pointer type and any pointer to member types and also bool, there's no implicit conversion back to integral types. So very useful to use when you're zeroing out your pointers, when you are also working with Boolean expressions. So the last feature I'd like to talk about today is lambdas. Lambdas to me are the kind of the funnest new feature, simply because the syntax is so interesting, but it also solves some real world problems. I mean, anonymous functions are used and callbacks are used all over C++ and in the STL. Simple example would be the standard sort, where you're providing two values that need to be compared, and the third argument is some type of callback. Now you can do this in C++ 11 using a lambda expression. So that you don't have to define a class outside of that, type def it, and then pass it into that. For each, you can just write it right there in line. The other way that it's really interesting is that it can be used to define or implement closures. And closures are anonymous functions that capture variables within the scope that it's living in. So again, this is useful when you need a type that is living in the function scope that you're living in, but you otherwise would have no access to it. You'd have to pass it as a parameter otherwise. So in this case, the basic syntax looks like the first thing you see is the capture list. This is in brackets. You can capture by value or reference by specifying the ampersand for reference and the star for value. You can specify the exact list of variables you want to capture. Or you can capture all by just specifying, like I do in this code sample, the ampersand. So that's saying capture all the variables in the scope by reference. Next, you pass the parameters in the parentheses. You have some optional stuff that you do here also, where you can specify things like exception attributes or a return type. So return type will use that arrow operator, and then the type at the right before the body to specify what the return type is. And then finally, the body within curly brackets. So in this example here, just taking it all kind of full circle, I create the standard vector of strings. I create a local variable called s. I iterate through it using auto in the ranged for loop to concatenate each of those elements into that string s. And so in order to do that, I need a reference to that s variable. So in my lambda, I say capture by reference. I'm taking no parameters, but I'm using that s variable that I captured, using the concatenation operator for each element through that container. And then lastly, I'll show that message. So let's take a quick look at that in action over here inside C++ Builder. So here is that same source code, and we are in 64-bit Windows, so we'll go ahead and run that. And if we set the debug in here, we'll watch each of these values be incremented. But what I really wanted to show you here in the last second is me building this C++ 11 code with 32-bit Windows compiler, linking and building and running. Okay, so there you have it. That's my C++ language overview. Like I said, there's lots of really cool features in C++ 11. These are some of the ones that I like and have used and starting to use more. For me, some of the biggies are the auto and range for loop. I've been replacing a lot of code with that to clean it up. I've also been using move semantics. I've updated all my classes with move constructors and such, and starting to use those more and more within my code as well. But there's a bunch of features to look at, and also, if you don't know, there's been quite a few publications as well. Bjarne Strustrup has a tour book as well as the full featured book on C++ 11 that was published this year, as well as a new book on the STL by Andre that's available as well, and a few others that are coming out. So let's open it up for any questions, David.
Okay, JT. Uday was asking, can you use MP4 and MP3 files in C++?
Sure. Yeah, I mean, that's more of a function of the framework support as opposed to the C++ language, but VCL and FireMonkey do support both of those formats.
Yep. Just check out the T Media Player component for VCL and FireMonkey. We don't support streaming protocols, but you can definitely load files of all kinds of formats, MOV, AVI, and so on, WMV, MP4, MP3.
Correct.
Yeah. Gregor asks a question, are you putting changes back into the Clang public repository?
We are, although not all of our changes are submitted or available, mostly because, some make sense, bug fixes. And Clang, the repository is more than just the front end. There's LOVM backend, there's LLDB, which is the new debugger, there's LD, which is the new loader, or LDD, which is the new loader. And we're participating in all of these projects fairly regularly, both in using them, fixing issues, and submitting those. We don't have all of our changes in the Clang trunk right now, especially the PME and RTTI stuff, for two reasons. One is we've been working with more stable versions as opposed to trunk, so that we can create commercial versions that we can support as we go out. And two, the changes are pretty large, so it takes time to turn those into consumable units, if you will, by the open source project to be ultimately put into the trunk. Our ultimate goal is to get these in the trunk because that saves us a lot of effort as well. But as of today, not all the changes are there, though we do participate in all these projects regularly.
Yeah, and you and other members of the team are active in the Clang community in all the meetings, right?
That's right.
Yep. Okay, let's see. I have to scroll up. So the question was about smart pointers. Are those compatible on all platforms, or again, just the ones with C11?
Just the ones with C11. So, and that's Win64 today, iOS and Android, and as you saw, Win32 is coming along as well.
Please confirm the use of override is optional. Does this mean override final can be abbreviated to final?
I believe so, because basically override is used in the inherited class to say I'm overriding this base class function. So if a base class function is listed as final, you wouldn't be able to override it anyways. So yeah, I think that that's a reasonable approach. So the override isn't going down the chain; it's going up the chain. If that makes sense, where you're saying I'm going to be overriding from the base class, that's what I'm referencing. Final goes the other way, which is saying anything below me cannot be overridden. Hope that makes sense.
Okay, there's a question by John about these are the usual things. When will something be available? And go ahead.
So
JT.
What I'd like to let you guys know is we will be having a public beta. We don't have exact dates yet, but we will be publicizing when it's available, and we'll absolutely be looking for beta testers.
Yeah, we'll keep you posted. Some people want Win32, some people want Linux. I want it all, but that's just me. Is it possible to use Boost with C++?
Oh, yes. We provide a version of Boost where we implement, or I should say test, a majority of the available features. We don't do it all, but we do a good percentage of it. You can, of course, pull in any Boost class you want and build it, particularly with the C++11 compliant compilers. I'd say this is probably a good question also, James, to bring to the libraries session that we're going to have on Thursday.
Yeah, that's it. 10 o'clock, compilers, libraries, and tools with the C++ compiler team. Yep. Let's see. Oh, just James adding, the succinct list of what features work with which versions of the compilers. And JT, we had that browser, I think it was CBuilder 4 or 6 that you worked on years ago, and we're trying to resurrect an interface mechanism for on the web or something for C++ builder users to see what they can use and can't use on different compilers, right?
Right. Yeah, we do all the testing to know what we support. So, yeah, to David's point, we are going to try to make that public. We're just figuring out the best way to allow you to browse it and get that information. We do publish on EDN C++11 features known to work with 64-bit Windows today, and that will be updated as well.
Yeah, also in the doc wiki, there's a section with the columns. I think one way to look at it is, one way to look at it, and I also blogged about it a while back, but one way to look at it, I usually point people for the Clang plus R technologies compiler. If we're using C11, C++11 or Clang 3.1, you can go to the Clang, I think there's a link if you put C++ status on the Clang page. I'll find that link. They have the different Clang versions and which parts of the C++11 standard are supported in the different Clang builds. I think it's status dot. Ooh, I shouldn't say. I'll find the link. But you can also just search Clang C++ standard status, something like that in Google, and you'll find the table on the Clang page that lists what's in different versions of Clang 2.9, 3.0, 3.1, and beyond. And then OS 10 support, people asking about C++11. Again, that's all the work that's going on across lots of platforms, right?
Correct.
And then C++ 14, same idea, Let's see, is it possible to compile Ace Tau with C++ Builder?
It is. We just released a patch, which you can find on the community blog. It's in the form of a gzip that you can then you get as a patch file that you can run with your favorite merge tool. It just defines the versions of the compiler within certain files, and we built the latest version of Ace Tau with that, and have tested against that as well, and we're working on submitting that back to that repository. So if you need to build Ace Tau with XE7, go get that patch. It's up on community.embarcadero.com in my blog.
And JT's blog. Okay, John Thomas. Oh, this is someone who's a network person, with a bit of SQL experience, how to automate number of custom tests. Would recommend C++ over Delphi. I'm heavy a database user.
I'd say both are excellent options. It depends on kind of where you may have a little more experience in one language over the other, or also it may also depend on what you're trying to do with language. C++ can have some benefits. For example, has a broader collection of STL containers. But Delphi also, being the language of the framework, also can be a lot easier to work with and interface with the framework. So if you're doing database work and you're focused on data and building applications, and you don't necessarily have a specific need for these additional features or container types, then Delphi would be perfectly suitable. But again, if you want to get more of the power of C++, take advantage of that, then I'd say C++ is definitely obviously the right option. So I would say it depends really on those factors.
Yeah, at the SQL and database level, they're very easy, and we have sessions for database access and lots of videos. Drop a database access component down, use FireDAC. You can talk to all databases.
And Kevin's also asking about REST, and I'll be covering that during the EMS session today, but I believe we have other sessions that cover REST as well, right, David?
Marco has a couple sessions, database, EMS, and also we have lots of videos about REST from previous CodeRages and RAD in Action. So REST and JSON, we've got lots of samples and also lots of videos and articles. So you can absolutely do REST. We have the REST client component set, REST client library, which makes it so easy to drop a TREST client component and then a TREST request, a TREST response, a response dataset adapter for taking the JSON and mapping it to a dataset and doing all sorts of things with it. So we have lots of documentation and samples for that. I don't know that we're covering a bunch of REST in general, although Serena talks about REST in her Internet of Things and convey backend as a service session. And Marco talks about it in his EMS SQL database access. So, and then we have, again, tons of articles and videos about using the REST components, both with Internet of Things, but also just connecting to REST services. You did a blog about using REST to get to, I think it was the Surf Watch REST service to get surf spots and things of that kind. Serena's done it,
Yep.
and I've done it as well. Yeah, so lots.
Yeah,
of
and basically REST is really straightforward with these components, and works just as well in C++ and is in Delphi.
Yeah, so Rob is asking about RTTI support. Will that improve for C++? It's currently below Delphi. Well, it's at the framework level and the RTL. You can use the Delphi RTTI. Just use the underbar Delphi RTTI. But I guess Rob is asking more about C++ language and library RTTI.
I suppose that's what Rob is asking about. I mean,
yeah, automatic
if
JSON
you're asking, will
conversion.
RTTI and C++ language standard improve? That's a good question. I don't think it's being actively discussed much in the committee right now. It's still pretty much relegated to the basics, which is around casting type of operations. Of course, the RTTI we put in the C++ builder is much more complete. And our goal is to support any of the Delphi-isms, if you will, that are part of the framework with the RTTI support in C++. So if there's something that's missing, we're working on it. Or if you have a specific requirement, like you mentioned, the JSON, then that's something I can look into. But yeah, that's our goal is always to keep our RTTI up to date and compatible with the Delphi side.
Yeah, and for JSON, again, we have libraries, components, the REST components I mentioned, data snap. There's a whole set of JSON conversion and migration functions. There's also the ability to map JSON to fields. So there's a bunch of that that's already built into the product through the components and so on. Let's see. Oh, somebody was asking about why we use C++ and not Java. And Anton, we've been supporting C and C++ since 1986 and C++ in 91. So we also had a Java Java. Oh. We have JBuilder. We haven't done anything with it in a long time. We did a lot of Java, but we've really been focusing on native code, optimized code, machine code optimizers for all these platforms, and that's why C++ and Delphi, right? And
if you look out in the future a little bit, or even now, this world of embedded, where C and C++ in particular, or compiled languages shine, are becoming much more predominant with the Internet of Things and gadgets and wearables. So it's actually a really good time to be in the native code compiled language market, because this is a critical, the requirements around some of these devices in terms of size and speed and access to the device can only be accomplished, or at least more easily accomplished, with the use of a native language like C++ or Object Pascal.
And then there was Louise asked about, is it possible to mix Objective-C and C++ in C++ Builder? On iOS, you can call through the Objective-C class to bridge between C++ to any code, but we don't compile Objective-C code ourselves.
Correct. The other way around works. I mean, Objective-C does have a C++ compiler built into it, as well as C, which is also based on Clang. But we don't use that to build Objective-C. I guess in theory you could, because it is the same front end, but it's not something we've tested or plan to support.
Yeah, we don't compile Objective-C source code. So, but again, the same way we have FireMonkey go to iOS API and to other libraries that are compiled with Objective-C, as we go through the Objective-C class bridge. I think we have several examples that show how to do that. One is the system INI sample, I think it's called, or it gives you an example of using Objective-C and using JNI, the Java bridge on Android, to get the operating system information, operating system release, and so on. So, and you can look at the RTL source code for FireMonkey and the components, for example, location sensor and so on, to show how we get from C++ and Object Pascal into the platform APIs for Windows, Mac, iOS, and Android. Oh, interoperable with Swift callables. Stephen, I haven't looked at Swift. Have you looked at anything, JT, about Swift?
I haven't.
I don't know, Swift. Okay. So that's something we'll have to just see. I mean, if it compiles to a static library that has the same interface as Objective-C, you could use the Objective-C bridge, but I haven't looked at it. Let's see. Okay. Okay. I think that's most. Let's see. Talking about FireMonkey, any plan to use the platform to create web apps?
Well, I guess it depends on what you consider a web app. Will we render FireMonkey UI controls to a browser? We don't have any current plans to announce there, but we do certainly have technologies that you can use to access via JavaScript-based apps in the browser, such as EMS in particular, Enterprise Mobility Services. We'll be doing a talk on that today at 3. But you can certainly build web apps that are able to go call back into backend or middleware modules that are built with C++ Builder, built with Delphi, that can be used in web apps.
Yeah, there is a third-party component set called FMX Web that is from a separate company that allows you to do some work in a FireMonkey type environment. But again, it's doing a sort of client bridge and so on. But you might search for FMX WEB and see if that fits something you may be trying to do. Okay, I think that's all of it. Let's see. Oh, there's some comments about Java. I'm just going to sort of go past all that. This is interesting. Any try of using C++ Builder with Embeddin or Emscripten? Is that? I'm not sure what Stephen's talking about. Embeddin and Emscription or scription maybe. I don't know about those. Do you know about those things, JT? Embeddin?
I don't, although I will check them out.
Okay. Oh, it's calling JavaScript from C++. I see. Okay.
Well, I mean, JavaScript can... I see, the other way around, C++ from JavaScript. Okay, interesting.
Okay. Okay, I love taking a look at that stuff. Okay, I think we covered the rest of it. And of course, it's not native code. Go C++. Yeah, we agree. That's why and I think if you want to ask some questions during Bjarne's, I mean, he'll talk about different languages you might explore, but again, for doing system development and a lot of cross-platform and native code, C++ is great for doing that. Perl interpreter into C++. I've seen some Perl libraries. We have a regular expression library that uses Perl-like syntax that's part of the RTL. And I know some other people have embedded other libraries for Perl, Ruby, and so on into C++ apps. So you might check out some of those and see if they give you the source code where you could create some library or some code or call some remote object or DLL. But we haven't done anything specifically with Perl. Here's Carl is saying Clang supports platforms 32 and 64-bit. Well, JT, why don't you explain again? We were the first ones to take Clang and do Windows versions of any kind, right?
Right. I mean, let's just separate a few things here. Clang doesn't support anything bit. Clang is a C++ front end. LLVM supports Intel 32, Intel 64, ARM, and various other CPU architectures. So when you talk about building a Windows application in 64-bit or 32-bit, it's more than just generating Intel CPU code. I mean, certainly we could do that today, and you can write command line apps all day long, but that's not the product we sell. We're not selling just a compiler. We're selling a development environment. We're selling a framework that allows you to build very complicated applications very quickly. And so there's a tremendous value in those frameworks. And also to build object frameworks that work with those environments, you also have to take care to consider things like exception handling. In Win32, when you're talking Win32 API, you also have to deal with structured exception handling, which is the only platform that really has that built-in exception handling approach. We're going to talk about exceptions also on Thursday, so this is a good question for that. Yep. Additionally, calling conventions. So 64-bit has essentially one. 32-bit has, I'd say, probably at least 10 different calling conventions. So there's a lot of specifics that you don't necessarily think about when you're just using a framework that relate to an executable being able to run on that operating system and call into that platform so that you can do something meaningful on that platform. Again, if we were just building console apps, we can do those now, but it's not as valuable as being able to use the full framework and to interact with the platform. So the difficulty has been is that Clang, for the most part, hasn't really cared about Windows as a target platform. We were the first to bring Clang to Windows in 64-bit and Windows, and working on the 32-bit version as well. But it is actually a lot more complicated than it may appear at first glance, with the fact that of course LLVM can just generate those instructions. Where's the challenge? So that's I hope that helps explain a little bit why it takes a lot of work to get a commercial compiler and all the frameworks and platform integration that's required to make this product work.
Here's a question. It's how to mix Pascal Delphi code and C++. Gahendra is saying that C++ Builder Pro with mobile add-on doesn't allow using pass files to compile into mobile projects?
That actually sounds wrong to me. That should be allowed.
Because
I don't know. We'll have to go look into that. On the app method product, we don't allow that, but we do allow it on the C++ Builder product. So I don't know the answer other than it should work, and we'll have to get back to you.